I will be honest, I used to think the bias variance trade-off was just another boring curve in the textbook. I could even draw it perfectly in the exams. But deep down, I never felt what it actually meant. Then, while working on one of my first machine learning projects, my model kept giving strange results. Sometimes too simple, sometimes completely random. And that is when I realized this was not a coding bug. It was bias and variance fighting each other behind the scenes. Once you get this, you will start seeing it everywhere in regression, deep learning, even in massive language models like GPT. Hey, I'm Akash Gupta, and in this video, I will help you feel the bias variance trade off, not just memorize it. We will understand what it actually means, why it happens, and how it decides whether your model learns or just memorizes. So let us start in simple human language, no formulas, no jargon. Bias means your model keeps giving wrong results in the same way again and again. It is like a student who always writes the same wrong answer no matter how many times you explain it. Similarly, variance means your model's answers keep changing every time. Sometimes it is perfect, sometimes way off. It cannot make up its mind. In short, bias is consistently wrong and variance means inconsistently right. To visualize this, let us talk about archery. All arrows landing together but far from the center. That is called high bias, low variance, where center is my target. And arrows scattered all over, that is low bias and high variance. And your machine learning model behaves exactly the same way. Now let us see what that looks like in actual machine learning terms. Look at this first graph. It's a simple linear regression line trying to fit all these data points. See how the red line misses most of the blue points. It is too straight, too rigid. That is what we call high bias. The model is making the same kind of error everywhere. But notice, if you take another data set from the same distribution, it will still draw a similar straight line, meaning low variance. It is consistent but consistently wrong, like a student who gives the same wrong answer confidently every time. Now look at this next one. Here we made the model super flexible. It now perfectly hugs every little zigzag of the data, that is low bias, because it fits the data almost exactly. But it is also high variance, because if you train it on a slightly different data set, this red line will go completely wild. It is like a student who memorized every single example from the book, but the moment the question changes, they panic. That is called overfitting. So if you get a good accuracy on your training data, it might not be good at all sometimes. Now, let us zoom out and look at the bigger picture. How bias and variance move as your model becomes more complex. So in this diagram, you can see on the x-axis you have model complexity. As you move right, your model gets more powerful, more layers, more parameters in the machine learning or deep learning model. The red bias curve starts high because simple models assume too much and gradually decreases as your model becomes smarter with more complexity. The variance curve starts low because simple models are stable but shoots up when your model becomes too flexible and starts memorizing everything and keep touching each and every point. Add them together and you get the U-shaped total error curve. The lowest point of that U is your sweet spot. That is where your model has learned enough to generalize but not so much that it memorizes noise. In machine learning terms, that is called optimal complexity or the point of generalization. This one curve basically tells you the entire story of machine learning. Let us bring this to real life examples. First, I can talk about house price prediction. A simple model says price is equal to m times area plus c. It ignores number of rooms, location or age. It is high bias. Too simple, misses the real story. Now you add 50 features, number of windows, tiles, ceiling, height, and suddenly the model fits training data perfectly. But on new houses, it fails badly. That is high variance. Memorized old houses, forgot how to generalize. The ideal model sits right between those, captures important patterns but ignores noise. A student who memorizes every line, high variance. that is called overfitting. Another who just reads headlines, that is called high bias, and that is called underfitting. The topper, who is the topper? Understand concept, practices examples, and applies logic to new questions as well. That is called generalization. That's your perfect model. So technically, what is going on is simple. Let us summarize it. High bias, it means the model is too confident about its wrong assumptions. It assumes the world is simpler than it really is. High variance, it means the model keeps changing its decision based on small data differences. It is too reactive. And as you make the model more flexible, it gains understanding but loses stability. And that is the bias variance trade off, the eternal balance between learning enough and not overlearning. So, in real projects, you don't directly calculate bias or variance. You control them by how you design your system. If your model is overfitting, add more features, use deeper networks, or reduce regularization. If your model is overfitting, simplify the architecture, add regularization, or gather more data. Techniques like dropout, early stopping, and cross validation help you maintain that sweet spot between both. If this made bias variance finally click for you, hit like, subscribe, share it with a friend who still fears this curve, and subscribe for more simple and human AI explanations. I was once just as confused about this as you. Now let us make sure no one else memorizes that curve without truly feeling it.